Okay, so maintaining extra link, this extra link. So what is its advantage? Okay, that each node is maintaining extra link. What is its advantage? Let's explain it. Suppose that this user, it wants this peer, it wants to share a file tare zameen pe. So the idea of this peer is 011 0011. It's a binary representation, so integer value is 3. So this user will apply hash function or the title of the file name tare zameen pe, and it produces a hash value 1100. So now who is responsible for this key? The one which is closest to this key. So who is closest? So this node will check the difference of this key with itself, with its predecessor, with its successor, and with this neighbor, that is 2 hop away. So their differences is this one. So you can see that the lowest difference is 6, and this is 100, and this one is this neighbor. So if this neighbor will forward this file to this neighbor, you can see it. This pair will forward the file to this one because this one is closest. And similarly, when this node receives the file, so it will compare the key 1110 with itself, with its predecessor, with its successor, and with its successor, and with its 2 hops away node. Okay, so again it will forward it to 2 hops away. So you can see that this file is moved in 2 steps. So it will take less time. It takes less time. Okay, so this is the advantage of maintaining extra neighbors, and these are called these extra neighbors. They are called shortcuts. So by maintaining more numbers, so it definitely increase the overhead, but it also reduce the lookup time, as we have explained in this figure. Okay, so this is the working that we have explained. Now what is peer churn? Suppose a peer 5, suppose it wants it to leave the network, so it switch off itself or it leaves the network. So if the peer P5 it abruptly leaves the network, then this circle this cord gets disconnected. So how to connect it again? So in this case, each pair share its predecessor and successor with its neighbors. For example, 5 share its successor 8 with its neighbor 5, with its neighbor 4. So 4 comes to know that after 5 there is a predecessor 8. So in case 5 abruptly leaves the network, for example, pair 5, it doesn't receive keep alive message from 5. So 4 comes to know that 5 is no more in the network. So in this case 4 will connects with 8. Why? Because pair 5 has already shared with the 4 that its successor is 8. So 4 comes to know about it. So 4 will connects with the 8. Similarly, if a new pair wants to join the network, for example pair 13, so where pair 13 will be placed? Pair 13 will be placed between 15 and 12. How it joins? The pair of 13, it joins the network by contacting any pair. For example, it contacts pair number 8. So when it contacts the pair number 8, so pair 8 forwards the request to according to its LID, who is successor of 13. So 8 will compare 13 with itself, with its predecessor and successor. So what is the difference? So the difference between 8 and 13 is 5, 8 and 5 is 8, 8 and 5 and 13 is 8, and 13 and 10 is 3. So 10 is closest. So 8 forwards request to 10. Similarly, 10 forwards is to 12, 12 forwards is to 15. So 15 is the closest. So in this is successor for 13. So 13 will be placed between 12 and 15. Okay. We have discussed just chord structure. This is called chord circular DHT. There are different structure proposed in for other DHT structure that are available. You can see cane, you can see cadimlia, etc. So many more are proposed in the literature and they are used in practice. Now we have discussed that there are two types of protocols. The one which is called public protocol. Public protocol is the one whose RFC is available, whose working functionality is available, is defined. For example, HTTP, TCP, DNS. And proprietary application protocol, these are protocols whose working are not known. For example, Skype application layer. Okay. So Skype is a case study of P2P system. It is using a P2P architecture to communicate between peers. It is a proprietary application, so its working is not known. But through reverse engineering, the people can find that how it works. So it works by having super nodes. There's some peers they are connected to a super node. Okay, a super node is constructed. So the peers are connected to the super nodes, and the super nodes are connected with itself. Super nodes are connected with itself. And the super node, the index map and username to IP addresses and distributed over super nodes. So how it is indexing indexing means that which peer is available where. So they are using the username and are mapped to IP addresses. Okay. So the peer-to-peer architecture we will discuss in chapter number 4 and 5. They doesn't work with the net, behind net. We will discuss what is net in chapter number 4 or 5. What is net and how it make it difficult, even impossible to use the P2P system. So then we have some techniques to provide the working of P2P system behind net. So for this purpose we call net traversal problem. It is solved by the Skype, but they don't show how they have solved it. Okay, but anyway, we will discuss net and then we will revisit the Skype again in chapter number 4 and 5. So up to now it is finished. This class is now completed. Okay.